Running Android games on Windows 10-11 using QEMU+Hyper-V+virglrenderer+Bliss OS. If you are trying to play Android games on a PC running Windows 10-11, your best bet is to install some Android emulator, not Android Studio from Google, although technically you can, but performance won't be great. Sure, there is WSA on Windows 11, but from what I heard, performance is not great. There is also Google Play Games, but apparently it only supports x86 games. This article focuses on ARM games. I am going to show you an alternative. Roll your own Android emulator using QEMU-D. You'll need a system that meets the following requirements: 64-bit Windows 10-11 with Hyper-V enabled, powerful enough to run a virtual machine with 4 FPS and 4 GB RAM. Ideally your system can run 8 threads and has 8 GB plus RAM. Discrete GPU, although an integrated GPU may work. Enough disk space to download and compile QEMU and host the Android VM and related files, around 40 GB. Most traditional Android emulators do not work with Hyper-V enabled, so make sure you are okay with this. You can always turn it off once you are done with testing. Refer to this article on how to enable it. Now, before we get started, be warned that some technical expertise is required because we'll be building QEMU from source and also installing Bliss OS, Android OS, in a virtual environment. It is actually not that difficult, so if you follow the instructions carefully you should be able to do it. First you'll need to get MZs 2, which is the platform we'll be using to build QEMU. The latest installer as of this writing can be found here. Here. After it is installed, if you check the box to run MZs 2 now, it will fire up a UCRT64 terminal by default. Run the following command to update MZs 2. $Pac-Man shoe. Proceed with the installation/update, and after everything is done, the terminal will close. Reopen the UCRT64 terminal and continue updating the rest of the packages. You'll also need to install a bunch of prerequisite packages in order to build QEMU. QEMU. $Pac-Man suit. Now you have an environment that is ready to build QEMU. First make a working directory. I personally like to call it code since we'll be compiling source code, but you can call it whatever you want. $mdir code. Go into this directory and download the latest version of QEMU. As of this writing it is 7.2.0. $cd cd codes wj download. Extract the tarball and cd into the directory. $tar xvf QEMU 7. Download the patch to allow building of virgrenderer support for QEMU on Windows. $raw.githubuser. Now you're ready to configure and build the patched QEMU. $? Go for a coffee break as it may take some time. time. After the code is compiled, install/copy all the QEMU related binaries and libraries over to a new folder so it becomes portable and you can run it outside of the MZIS2 environment. Environment. $make dster equals. Now we will set up the virtual environment that will be run by QEMU. First, you will need to create a virtual disk image to install the Android OS into, by running the following commands. Commands. $pack. The image file may ultimately grow up to 20 gigabytes as you install Android apps, so please make sure you have enough space in your drive. You can adjust the size to whatever you want, but 20 GB is a good starting point, which gives you enough space for the Android OS and also to install a few games for testing. We will need to generate a UEFI firmware that QEMU can use on Windows. Windows, $catmzir.fd. You can now either stay in the MZIS2 environment or just run everything from Windows PowerShell. In this example we will run it from the PowerShell. Start by copying the QEMU directory to a separate location. You can find your MZIS2 home directory on Windows Explorer via the path c:\mzis64/home/username, so just copy/move the contents of c:\mzis64/home/username/QEMU to a separate location, say c:\QEMU. You'll need to download an Android OS ISO to install into a virtual machine to be run on QEMU. For this article we will be using Bliss OS 15.8.2, Bliss v15.8.2 x86_64 unofficial GApps 20221214.iso. Normally Bliss OS test builds are available here, however there are some issues with the newer builds, so we're going to be using a slightly older version available from my unofficial mirror. Once the issues are fixed in newer versions of Bliss OS, I will update the article. This version of Bliss OS runs Android 12. 12. Now it is time to start up the virtual machine booting off the Android ISO. Make sure that both the ISO and the UEFI firmware are in C:\/QEMU or specify the correct location in the command below. C:\/ I didn't specify any CPU options, because that is hardware, CPU, specific, so if for whatever reason QEMU does not start or performs poorly, you may try different options and see what works best. For my i7 CPU for instance, CPU Westmere works fine as well as CPU KVM64. You can find out available options by running CPU. Note there is a bug with using CPU Max when Hyper-V is being used as the accelerator. Once the VM is started and boots off the ISO, you will be presented with this screen. Scroll down and choose Installation. Installation. You will need to create two partitions. First one is for UEFI, boot, the second one is where the bulk of Android data will be stored. Select create/mod, select new partition name, another partition. It should now using the arrow keys, now use the select X4 format, select yet grub2, choose yet format. For this question it doesn't really matter what you choose, since future releases of Bliss OS remove this option altogether. After the installation is complete you can close the QEMU window and run the following command to boot your newly installed Android OS off the virtual disk directly. It should now look something like this. Using the arrow keys, choose right together. After the installation is complete, you can close the QEMU window and run the following command to boot your newly installed Android OS off the virtual disk directly. C:\\. I skipped all the Google related setup, so if you are uncomfortable entering those information, you don't have to do so. They are totally optional. If for whatever reason you want to boot off the ISO with your disk image mounted, you can use the following options to start QEMU. Drive file equals bliss15.img, if equals none, it basically replace the original option drive file equals bliss15.img, if equals virtue with the one above. After all the hard work, we are now ready to play some games. The following are 2 ARM games you can install into Android for testing. Arknights, Armiyabi V7 AAK 32-bit, Gundam U.C Engage, ARM 64V8 AAK 64-bit, both require ARM translation, which is provided by Lipudini. Download the Android SDK platform tools for Windows and extract the zip file, then go into command prompt and cd into that directory. You can now use the AUDUB command to install APKs directly into Android. >AUDUB game.app. Note the linked APK for Arknights is in ZAPK and cannot be installed using AUDUB directly. You can either push the file to Android first using AUDUB and then use an installer such as Psy, or just download using Google Play Store, Aurora, or other app stores such as QAPK. Here are some screenshots of games running on our Android emulator.
U.C Engage.
Emulator. Obviously not all games will work, some detect root/developer options/Android emulator and will simply crash, but in general the setup is functional. There is currently a known issue with playing videos in YouTube, Nikkei as well as Gundam U.C. Engage. You will notice some strange artifacts such as the following. Following. To work around the issue, you can edit the boot options. At the boot prompt, hit E to edit, add FMPEG_codec equals 1 at the end and hit F10 to boot.
Gundam U.C.
スペースコロニーサイド7に侵入したジオン軍の偵察部隊は連邦軍が極秘に開発していた新型モビルスーツガンダムを発見した。 トレーラーに横たわる機体を破壊しようと試みるザク。しかしガンダムのコックピットにはサイド7の少年アムロ・レイの姿があった。アムロのとっさの操縦によって目覚めるガンダム。ついにガンダムが大地に立つ。
Boot. Lastly, some games do not function well with clicks, so we'll need to make Bliss OS emulate taps with clicks. Go into settings greater than Blissify greater than miscellaneous and enable force mouse click as touch and you're all set. Set. I think this is a good starting point to allow us to develop a full-fledged open-source Android emulator for Windows, and potentially Mac and Linux as well. As a reference, there are similar existing open-source projects like PlayCover for Mac and Waydroid for Linux. Most recently I also learned about Trinity Emulator, which sounds like a pretty cool project as well. Thanks to Discord users XDR, QuackDoc, Sinjosai and Humberboy154. In the future I will be working on some automated scripts for installation as well as performance tuning and benchmarks, so please stay tuned. If you have any questions and/or suggestions, the Android EMU community has a Discord server as well as a subreddit, so you can usually find me there.